Hi, my name is Andrew Boswell, and today I'm going to be talking about microplastic pollution. So first I want to talk about some of the impacts of microplastic pollution, and I want to start by defining microplastic. So a microplastic is any small plastic piece that's less than 5 millimeters long. So these are very, very small pieces of plastic. Microplastic is created either separately as a bead, and companies use them, they put them in all kinds of different products, or they are created by weathering. So bigger pieces of plastic get weathered by water or by wind, and they disintegrate, and they eventually break into smaller and smaller pieces and become microplastics. So some of the direct impacts of microplastic pollution are toxic additives, which cause infertility. So the toxic additives that they add into the plastic, when they're ingested, they can cause infertility in a great range of creatures. There hasn't been a lot of research that's been done on this problem, but the research that has been done seems to suggest that they can, in larger amounts, cause infertility. There's also flame retardants that are added to the plastic as it's created, so that it's less so it's flame resistant, and these are carcinogens. So when you ingest those, they can cause cancer. And then there's some indirect impacts of microplastic pollution. There's bioaccumulation. So basically, as especially microplastics in the water column, they get ingested by fish, smaller fish at first, and then bigger fish eat the smaller fish. They eat a lot of them, and so they get more and more plastic that accumulates inside of them. And then another indirect impact would be growth in mollusks is inhibited when they are formed around microplastics. And then they also accumulate contaminants. So microplastics, they may look smooth to the naked eye. However, when you look at them under a microscope, they have many, many, many tiny little abrasions, and those can actually collect different viruses and bacteria. And so they can increase the viral and bacterial load in water. And then over on the right, we have some of the different ways the microplastics enter the environment and can enter people eventually. So we have extraction and transport, daily consumer use, refining in factories, and then waste management. And all of these different ways cause microplastics to enter the environment, and then humans can inhale them, they can ingest them, and they can come into contact with people's skin as well. So here's some of the regulations that deal with microplastics. The first is the 2006 Save Our Seas Act, and this was reauthorized in 2012, 2018, and in 2020. And this basically is a piece of legislation that just tells NOAA, the National Oceanic and Atmospheric Association, that this is an issue. Marine debris is an issue, of which microplastics are a part, and it tells them to work on the issue. And it also requires them to create scientific reports and studies on the different aspects of the issue as well. And then it established the Marine Debris Program, which is an NGO that is a charitable organization that funnels money towards NOAA so that they can actually work on the issue. And we also have the Microbead Free Waters Act, which was signed by President Obama in 2015. And before 2015, there were thousands of personal beauty products and toothpastes actually that had plastic microbeads inside them. And so this actually banned those in all of those products. One tube of toothpaste before 2015 could have up to 350,000 plastic microbeads inside them. So that's a lot of plastic. And then each year before this legislation was passed, over 2.9 trillion microbeads entered US waterways. Unfortunately, because plastic takes hundreds to thousands of years to fully disintegrate, all of those microbeads that had entered the water previously because of these different types of products, they're still there. So it doesn't deal with the existing microbead problem, but it does help to prevent some from entering the water as it is now. And we have some California regulations. We have the Ocean Protection Council, which was created in 2004 by Governor Schwarzenegger. And it's basically a group that allows a bunch of other groups to coordinate with it. So it coordinates activities of ocean-related state agencies, and it helps improve effectiveness that way. And then it establishes policies to share scientific data, and they also identify and recommend changes to the California legislature. And one of these recommendations was the 2022 California Ocean Litter Prevention Strategy, which was a multi-year roadmap that was released to help California manage microplastic pollution. And they also suggested some solutions to preventing that pollution. First of all, eliminate plastic waste at the source, and then intervene within pathways that microplastics use to get into California ocean water and rivers as well. And they also wanted to engage and inform the public about these sources, impacts, and solutions. So here's some of the issues for microplastic within the US. In every in oysters and mussels and other mollusks like that, there's about 50 particles per serving of those of microplastic within those creatures. We also have freshwater fish. About 12% of freshwater fish in the US show signs of microplastic pollution, meaning they've ingested microplastic beads. That number jumps way up when it comes to ocean species. About 70% of consumable ocean species show microplastic pollution. There's about 1 particle per 8 gallons of Great Lakes tributary water. That's not a lot. Our inland waterways are relatively clean, relatively absent. Microplastic pollution is relatively absent there. We have 112,000 particles per square mile of Great Lakes water. Again, that's not a lot of plastic. Great Lakes are relatively clean. And then we have 1,285 particles per square foot of river sediment. So that's actually kind of a lot, relatively a lot compared to the amount that's in the water column. Eventually, microplastics do settle down and they settle into the sediment. So it basically builds up there over time. So there are some solutions, as I previously mentioned. The number one solution to stopping microplastic pollution is to stop making plastic or to create less of it. Because anytime you're making plastic, some of that, a percentage of that will end up as microplastic pollution within the ocean or in our inland waterways. We also have trash capture devices. These are usually installed in the ends of rivers so that plastic does not reach the ocean. It gets flushed downstream from inland areas and it reaches these trash capture devices, and they're able to pull it out of the water before it reaches the ocean, before it can weather enough to become microplastics. These systems do not clean up microplastic pollution. If there's already something that's microplastic in the water column, that's not what these systems are for. They're not sensitive enough. They don't pick up small enough particles to be able to clean up microplastic pollution that's already in water. So that's something that's going to have to be developed. We also have incentives to use less single-use plastics. Single-use plastics are terrible because you only get one use out of them, and then they go to the landfill. Obviously, not all of them make it into the landfill. Some of them end up in the ocean, where eventually, like I mentioned before, through weathering, they'll turn into microplastics. And then finally, we have microfiber lint screens and dryers. So these are teeny, tiny little screens, more than the current lint screens that are in dryers as of now. They need to be even smaller than that to be able to capture microplastics from clothes. These are synthetic fibers like polyurethane, create microplastic pollution, and these can be aerosolized. They basically enter the air column, and they can be blown all over the place. And a lot of the time, they end up in the water because of wind. So these are all the different solutions that can help with the microplastic problem. And that's it.